Hi everyone. In this final video for division of polynomials, we're going to look at how we can use a slightly different method to factorize our polynomials. It's related to division because it uses an observation of what we get when we do division to set up a different way of solving these kinds of division problems. Okay, so first of all, when we divide polynomials, okay, we do some kind of dividend, some kind of polynomial divided by a smaller polynomial or a lower degree polynomial, and we end up with this quotient thing on top of our division bar plus the remainder, that number that we get at the end, divided by our original divisor. Okay. Now, again, if I can multiply both sides of this equality here by the divisor, if I multiply the left-hand side by divisor, I just end up with my dividend. If I multiply the right-hand side, I end up with my divisor times that quotient that we get up the top, plus just the leftover number that you get. Okay. So, what does this mean for us? Well, if we want to divide, say, this polynomial by x minus 3, what I can do is I can rewrite this problem as saying this original polynomial, x cubed minus 7x squared plus 5x minus 4, it's equal to x minus 3 times some other polynomial that you would get as your answer up the top of your division line, plus some number that is left over. Okay, how do I know that this polynomial here is going to be a quadratic or have a degree of 2? Well, at the end of the previous video, I said that if you divide a polynomial of degree n by a polynomial of degree m, the polynomial that you end up with will have a degree of n minus m. In this case, n is 3, m is 1, 3 minus 1 gives you 2. So I know that my answer will have the form of a quadratic. Okay. If I divided by, say, x squared minus 3 instead of just x minus 3, I know that my final answer will have a form of a linear, because 3 minus 2 gives me a power of 1. So I'd end up with something like, whoa, what happened there? I'd end up with something like ax plus b instead of ax squared plus bx plus c. And we'll see that in a couple of minutes when we do an example. Okay, so we can actually divide our polynomial, first of all, by setting it up like this. And this might look familiar to you. Okay, we did this in the last sequence of videos when we introduced polynomials. This is a setup for the problem of equating coefficients. Okay, because I know this polynomial on the left is equivalent to this polynomial on the right, and once I expand this polynomial on the right all out, then I can equate coefficients to solve for my values of a, b, c, and r. So let's do that here. Okay, so we're going to expand this right-hand side, and then we're going to equate coefficients, and then we can determine the values of a, b, c, and r, and then I can actually write my final answer without actually doing any division. Okay, so let's expand this out. Now, it might not be obvious to you, but this value of a here, you should see that, well, my leading term of my dividend is just x cubed. There's no number in front of that. And the only way that that can happen when I multiply x by this term is if a is equal to 1. Okay, I'll leave the a there for now, but just make a note of that you don't technically need to have that a there, because you already sort of know that it's going to be a 1. So whether or not you want to keep that in your working out, that's up to you. I'll leave it here for now for completeness. So let's expand all of this out. X times ax squared is ax cubed. X times bx is bx squared. X times c is cx. Move on to the negative 3. So negative 3 times ax squared minus 3ax squared. Negative 3 times bx minus 3bx, negative 3 times c minus 3c. So we've expanded all these things out and we've got this plus r stuck on at the end. Okay. Now, back when we did the equating coefficients a few videos ago, what we can do is pair up the terms that have the same powers of x, and I can factor out the coefficients of those powers to create just sort of one coefficient in terms of two unknowns. So I'll leave the ax cubed as it is because I can't pair that with anything else. The bx squared can be paired with the minus 3ax squared. Okay, and then I can factor out the x squared, and that will leave me with b minus 3a. So I can write my next term as, in brackets, b minus 3a times x squared. Okay, if I expand that out again, I'll get these two terms back. Okay, but we've finished them off. Next, I've just got the x term, so I've compared cx with minus 3bx. I can factor out the x from those two terms, and my leftovers will be c minus 3b times x. And finally, we've got this sort of constant bit at the end with no x in it, and I can just do plus, in brackets, 3c plus r. So that would be our constant term. Now we're ready to equate coefficients. So you look at the left-hand side, you say, okay, what's the coefficient of x cubed? It's a 1. What's the coefficient of x cubed on the right-hand side? It's an a. So that tells us that a has to be equal to 1. Okay, and that's what we said at the start of this problem. Next, we look at the coefficient of x squared. So on the left-hand side, it's negative 7. On the right-hand side, it's b minus 3a. So I can say that b minus 3a equals negative 7. I already know that a is equal to 1, so really I've just got b minus 3 equals negative 7, and so I can add 3 to both sides and get b is equal to negative 4. Next, you can look at the x coefficient. So on the left-hand side, our coefficient is 5. On the right-hand side, our coefficient is c minus 3b. So I can say that c minus 3b is equal to 5. From here, we already know that b is equal to negative 4. So I can substitute that into here and get c minus 3 times negative 4 equals 5. This will turn into c plus 12. Okay, negative 3 times negative 4 is positive 12, equal to 5. And subtract 12 from both sides, I get c is equal to negative 7. And finally, we've got the constant term. On the left-hand side, the constant term is negative 4. On the right-hand side, it's negative 3c plus r. So I know that negative 3c plus r must be equal to negative 4. From here, I already know that c is equal to negative 7. So I can substitute and get negative 3 times negative 7 plus r equals negative 4. Negative 3 times negative 7 is 21 plus r equals negative 4. And I can subtract 21 from both sides, and I in fact get r is equal to negative 25. Okay? So that means when I do the division, let me use another color. So when we do the division, x cubed minus 7x squared plus 5x minus 4 divided by x minus 3, I would end up with an answer of, well, this quadratic with the values of a, b, and c that we've determined. So I can write it out as x squared minus 4x, because b is negative 4, and minus 7, because the c worked out is negative 7. Plus the remainder bit. Okay, now remember, when we do our long division, we do, blah, 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 divided by blah, blah, blah. We end up with x squared minus 4x minus 7. We do the whole process. We'd end up with negative 25 down at the end. Okay, which means that we've got to stick on that remainder at the end of our answer. And the way that we do that is we write our remainder divided by the divisor, which in this case is x minus 3. Okay, so that's the answer to this division. And notice we actually didn't even do any division to work that out. We simply used the fact that we know that we're going to get a quotient that would be a quadratic. The quadratic would have coefficients of some kind, a, b, and c, and there might or might not be a remainder at the end. Okay, and then we've just expanded all of this out. We've said our original dividend, our original polynomial, is going to be equal to x minus 3 times our answer, plus a little bit of a remainder if there is one. And then we just equated coefficients. Okay, and then you can perform this long division yourself separately, and you should find that you'll get the same answer. Okay, here we've just used kind of a bit of a shortcut, knowing in advance that our answer will have this form. Okay, now first of all, why is it able to be written like this to begin with? Well, notice if this is our final answer, I can now multiply both sides by x minus 3, and what I would get is, I'm running out of room, x cubed minus 7x squared plus 5x minus 4. Multiply both sides by x minus 3, that's gone. And what I would get is basically all of this stuff times x minus 3. Okay, and one way that we can write that out is just x minus 3 times all of this stuff. I can multiply that separately and it would get rid of the x minus 3. So I'd get x squared minus x to the, 4x minus 7 plus, minus 25. Okay, and you'll see that it's got the same form as what we started with here. X minus 3 times our quadratic that we worked it out to be, minus the remainder, or plus the remainder, but the remainder is negative, so it's minus. Okay, so that's another method we can use to divide without actually dividing. Okay, let's see how we can do that in this example here. Okay, so we've got 2x cubed minus 6x squared minus 4x plus 12. We're dividing it by x squared minus 2. Now we haven't done any problems where we've divided by a quadratic polynomial, but the process would be exactly the same. Okay, exactly the same process. It's just that the answer you get at the end would in this case be a linear polynomial. Okay, because we know in advance that if we're dividing a polynomial of degree 3 by a polynomial of degree 2, we should end up with an answer of a polynomial of degree 3 minus 2, or 1, which is a linear polynomial. So using that fact, I can say that 2x cubed minus 6x squared minus 4x plus 12 is going to be equal to this factor here, x squared minus 2, times some linear factor, ax plus b, and there may or may not be a remainder at the end. Okay, that's for us to determine. And what we can do here is just expand this right-hand side out and begin equating coefficients. Okay, so expanding this out, I end up with, well, x squared times ax is ax cubed. X squared times b is bx squared. Negative 2 times ax is just negative 2ax. And negative 2 times b is minus 2b. And then we can stick the plus r on the end there. Okay. Now there's actually no sort of intermediate factorizing that we need to do like we did in the previous example, because there's only one term of each power of x. I mean, there's two terms for the constant term, but we can just combine that and pretend it's 1. So now we can equate coefficients. So looking at the x cubed, on the left, the coefficient's 2. On the right, the coefficient's a. So we know that a equals 2. So I already know what a is. Great. What about x squared? Well, on the left, it's negative 6. On the right, it's b. So that tells us b is equal to negative 6. Awesome. So we don't even have to actually solve any of these little equations that we're writing. We can double check that the x term would work out to be a equals 2 as well. So let's look at the x term. On the left it's negative 4. On the right it's negative 2a. So I can say that negative 2a equals negative 4. And dividing both sides by negative 2 does indeed give you a equals 2, which is what we already found. Finally, the constant term, we still have to work out what r is. On the left it's positive 12, on the right it's negative 2b plus r. So negative 2b plus r equals 12. We already know that b is equal to negative 6. So I can write this as negative 2 times negative 6 plus r equals 12. Negative 2 times negative 6 is 12, plus r equals 12, and that tells us r is equal to 0. So we actually have no remainder when we do this division. Okay, so what we can say is that when we do the division, whoa, don't want to go that far. When we do the division, 2x cubed minus 6x squared minus 4x plus 12 divided by x squared minus 2, we just end up with this linear polynomial with the values of a and b that we found. So we end up with 2x minus 6. And we could write plus remainder at the end, so plus r, but we don't need to. Or plus r over x squared minus 2. But we don't need to because r is 0. So that's our answer. Okay, and again, you could confirm this doing the long division yourself. And again, because the long division process would be exactly the same even though this is x squared and not x. Okay, so you can go and double check that yourself. You should get an answer of 2x minus 6. Alright, so that's another way that we can divide, in air quotes, without actually dividing if we use this process. Sometimes it's quicker than the long division, sometimes it's not. If you don't sort of get this process, you can always just do long division though. Okay, so this is a bit of it uses a little bit of a deep understanding of the knowledge of what's going on when we divide. It can be a bit confusing. If you don't fully get it and you understand the long division process more, just do long division. Nothing wrong with that. Okay. Anyway, we'll stop there. That's it for dividing polynomials. In the next set of videos, we're going to look at how we factorize and the properties of whether or not there's a remainder and how that affects the properties of your polynomials. Okay, so we'll stop here and I will see you next time.